We call it the speed of light, but that name, like many in science, is more tradition than truth. Because this limit, 299,792,458 meters per second, is not about light at all. Light just happens to reach it. Photons, the particles of light, travel at that speed because they have no mass. They don't accelerate up to it. They're born into it. They emerge into existence already riding the edge of the universe's limit. But the law is deeper than photons. It applies to everything. Any massless particle will move at this exact speed. Every influence, every change, every signal that can move through space-time without carrying mass is bound to this same velocity. Massive objects, protons, people, planets can only approach the limit, never reach it. The closer they get, the more energy they require. And at the speed of light, that energy becomes infinite. A boundary is drawn not by walls, but by the structure of the universe itself. This isn't about engineering. It's not about what we haven't built yet. It's a law written into the geometry of everything. And if you need proof, you don't have to look at light. You can look at gravity. For most of history, we imagined gravity as an invisible force, a tug, a pull, a signal that acts instantly. When the sun moved, the planets adjusted. When an apple fell, the Earth responded. But that's not how it works. In Einstein's universe, gravity is not a force transmitted through space. It is a curvature of space and time. When that curvature shifts, say when two black holes spiral together, it sends ripples outward, gravitational waves. For a long time, these were just theory predicted, but unseen. Then, in 2015, the Laser Interferometer Gravitational Wave Observatory recorded something extraordinary. Two black holes, 1.3 billion light-years away, colliding with such force that they rang the fabric of space-time itself. And those waves, they didn't travel faster than light. They traveled at light speed. Even the ripples in space-time obeyed the limit. Even the geometry of reality refuses to outrun itself. This tells us something astonishing. Light is not the exception. It is the proof. Proof that the speed limit isn't a quirk of electromagnetism. It's a boundary for all fields, all forces, all forms of information. Space-time moves in rhythm with its own rules, and nothing, not even gravity, can skip ahead. The law doesn't say, light is special, it says. This is how connection works. Nothing moves through the universe faster than the speed of causality itself. Light and gravity aren't the only messengers in the universe. Everything that exists interacts. And every interaction carries influence, a signal that something has changed. Electric fields shift, magnetic fields swirl, particles respond to forces they cannot see but somehow feel. But even here, in the invisible interplay of fields and particles, the speed limit remains. When you move a charged particle, when you nudge it ever so slightly, it creates a disturbance. That disturbance doesn't spread instantly. It ripples outward at the speed of light. But this isn't because it's made of light. It's because changes to electric and magnetic fields, what we call electromagnetic waves, propagate at that exact velocity. It doesn't matter if there's a medium or a vacuum. It doesn't matter whether you're near or far. The change moves no faster than the law allows. Even in the vacuum of space where no particles exist and no photons are visible, the field still obeys the limit. Because the boundary isn't imposed by environment, it's imposed by the structure of space-time itself. This holds true for every field we know. The strong nuclear force, the weak nuclear force, the Higgs field. Even in the mathematics of the Standard Model, influences respect the light cone. Which means that the universe doesn't just move at light speed, it processes itself at light speed. Reality updates, step by step, never faster than that boundary. And what about quantum mechanics? Surely that's where the strange things live. We've already seen that entanglement doesn't allow communication faster than light. But let's go deeper. In quantum field theory, the most successful framework in modern physics, everything is a field. Particles are excitations, disturbances in those fields. They pop in and out of existence, but the way they interact is strictly regulated. Even in the quantum vacuum, teeming with fluctuations, no influence travels faster than light. When a particle interacts with another, the information about that interaction spreads within a light cone. Outside that cone, there's no effect, no reach, no cause. This is built into the math. Operators in quantum field theory commute or cancel out outside the light cone. That's not an accident, it's a safeguard. The theory refuses to let influence jump the boundary. So even in the domain where things are probabilistic, where particles don't seem to exist until measured, where uncertainty rules, the speed limit still holds. Not because the quantum world is tame, because even its wildness is internally consistent. And that's the real revelation. Speed limit is not a law for macroscopic objects. It's not a ceiling for rockets. It's a fundamental limit on the transmission of any effect, anywhere, at any scale. Whether it's an electromagnetic pulse, a gravitational ripple, or a shift in a quantum field. The message travels no faster than light, because faster would mean causality breaks. And causality, it turns out, is more precious than immediacy. There's a moment when we look at the cosmos and think, surely this breaks the rule, because the universe is expanding, not slowly, not modestly, but at a rate that seems to fling galaxies apart faster than the speed of light. So is the law broken? Has nature made an exception? Not quite. Because galaxies aren't speeding through space. Space itself is expanding. It's not a race between objects. It's a stretching of the fabric between them. Imagine dots on a balloon. As the balloon inflates, the dots move apart. Move apart not because they're traveling, but because the space between them is growing. No dots are outrunning the others. The surface is changing beneath them. In cosmology, this is called metric expansion. It means that regions of space can recede from one another faster than light without violating the speed limit because no signal, no particle, no information is crossing that gap. In fact, for the most distant galaxies, their light may never reach us. It's not because it's slow, but because the space it's trying to cross is expanding faster than it can bridge. These galaxies pass beyond what we call the cosmic event horizon, a boundary not of light, but of knowability. And yet even here, causality is preserved, because nothing crosses that horizon in reverse. No message comes from beyond it. No influence reaches back in. The rule still holds. No usable information outruns light. Even the growth of space itself, wild and accelerating, is choreographed to maintain this constraint. But what if we try to break the rule anyway? Not with rockets, not with signals, with math. Theoretical physics has a long history of testing the boundaries of its own logic. And when we ask, what if something could go faster than light? The answer comes with an immediate cost. To travel faster than light, something must behave very differently from everything else we've observed. It would need imaginary mass, not zero. Not small, but mathematically imaginary. Its momentum, its energy, its relationship with space-time would all invert. These hypothetical particles have a name, tachyons. They appear in some exotic equations, often as curiosities or placeholders. But they bring baggage. Tachyons would always move faster than light. They couldn't slow down without crossing into paradox. It could be used, at least theoretically, to send messages into the past. And when that happens, causal structure collapses. You get the same loops, the same contradictions, the same breakdowns of logical order that plague all faster-than-light systems. But worse, the equations become unstable. Tachyon fields grow without limit. Quantum corrections spiral. You end up with a theory that destabilizes itself from within. Nature seems to reject them not with violence, but with silence. We've never seen one, never measured one, never needed one to explain any known phenomenon. And that's important. Because when mathematics leads to contradictions, it's usually the universe's way of telling us, this cannot exist. It's not just that faster-than-light particles are difficult. It's that they would break the very canvas the laws are painted on. We often treat physical laws like limitations, restrictions placed on what we're allowed to do. Gravity holds us down. The second law of thermodynamics says we can't undo entropy. The speed of light says we can't go faster. But these aren't just rules, they're definitions. They tell the universe not what it can't do, but what it is. And among them, the speed limit is one of the most fundamental. It's not a fence, but a framework. A signal can only reach so far in a given time. A cause can only influence what lies within its light cone. An observer can only see as far as light has traveled since the beginning. This creates structure, not just in physics, but in reality. Defines which events are connected and which are isolated. Draws the boundary between the knowable and the unknowable. When we say observable universe, we don't mean a physical container. We mean the region where information has had time to reach us. Beyond that, galaxies may exist, but for us, they're sealed off, not by walls, but by delay. That delay is built into the fabric of space and time. It's what allows a timeline to form. Without it, everything would be simultaneous. Every action would touch everything else. The cosmos would be one massive blur of effect without distinction. But with it, stories can unfold. Histories can be traced. Consciousness can organize memory, experience, and meaning. The speed limit doesn't just hold physics together, it holds narratives together. And it doesn't just protect causality, it defines identity, because you are who you are, in part because not everything can reach you at once. Your life has a direction, your mind has a before and an after. Your experience is sequenced, one moment at a time. That is what the limit gives us, not just delay, not just constraint, but order. A way for the universe to make sense. Not just to itself, but to us. And in that sense, the speed of light isn't just a constant. It's a kind of rhythm, the tempo of connection, the heartbeat of cause. It doesn't just bind the universe, it shapes it elegantly, relentlessly, beautifully. Everything you see has already happened. The stars above you are ancient. The galaxies and telescopes are fossils. Even the face across the room, lit by a lamp, exists in your eyes a few nanoseconds behind. You don't see the present, you see a reconstruction, a story patched together by light. Some of it fresh, some of it from 1 billion years ago. And yet, you live as if the world is immediate, as if everything responds in real time, as if now is something shared. It isn't. Not in the deepest sense. We live inside a delay, a symphony of photons, each one arriving on schedule, none arriving instantly. And this isn't a flaw, it's the reason experience has structure. It's why there is a before, a now, and after. Without that delay, time would have no rhythm, events would blur, causality would collapse. The universe would be a single flash with no memory, no sequence, no life. But because of this delay, the cosmos is patient. It unfolds gradually like a wave washing across the shore. It lets stars form and signals travel, and thoughts arise, not all at once, but in order. The speed of light isn't just about motion, it's about meaning. It gives the universe its tempo. It lets time play out, one moment at a time. It makes the act of witnessing possible. So no, you don't live in the present. Not really. You live in a moving horizon, where information catches up just late enough for you to notice, and just soon enough for it to still matter. The universe doesn't just move forward, it remembers, and it waits. It's for light to catch up. This is cosmic canvas, where the universe is not only studied, but painted in meaning. Until next time, keep asking, keep looking up, and never stop wondering.